Hello my dear students. Now we are going to do a problem on potentiometer. A potentiometer circuit is set up as shown. The potential gradient across the potentiometer wire AB is 2.5 volt per meter. So you see the circuit diagram, children. This is the potentiometer wire AB. On this wire potential gradient is 2.5 volt per meter. That means per meter length of this wire, per meter length, there is a potential difference of 2.5 volt. Also it is given that this two-way key, when this two-way key is not connected, completely switched off, then in this circuit, the ammeter reads 0.1 ampere. That means the current through this circuit is 0.1 ampere. And also it is given that when we put the plug between A and C, the balancing length is given as 40 centimeter. And when we put the plug between B and C, the balancing length is given as 100 centimeter. So now you have to find out what are the values of R and X. So for that, you see children, when we put the plug between A and C, the balancing length is 40 centimeter. That means whatever potential difference across this 40 centimeter length of wire, that is equal to potential difference across this resistance R. Therefore, here when A and C are connected, the potential difference across the resistance R, should be equal to potential difference across the 40 centimeter length of the wire, because balancing length is given as 40 centimeter, and also it is given 2.5 volt per meter. So per meter length 2.5 volt. So for 40 centimeter length of wire, we find the potential difference. Therefore, the potential difference across 40 centimeter length of wire is 2.5 into 0.4. If you calculate this one, you get 1 volt. Therefore, potential difference across this R is 1 volt. Similarly, when we connect the points B and C, that means when we put the plug between B and C, now the balancing length is given as 100 centimeter. That means the potential difference across R and X, potential difference across these two resistance together, that is equal to the potential difference across this 100 centimeter length of wire. Therefore, now we find out, that is when B and C are connected, the potential difference across the resistances together, both R and X, potential difference across these two resistances together is equal to 2.5 into 1 meter. Actually it is 100 centimeters, you have to convert into meter. So this we are getting as 2.5 volt. So now you got potential difference across R is 1 volt, and potential difference across R and X together, we got it as 2.5 volt. Now when this two-way key is completely switched off, means this portion, there is no connection here, the current through the circuit is given as 0.1 ampere. Here is given ammeter shows 0.1 ampere. So 0.1 ampere current passes through this circuit, 0.1 ampere. Therefore, the potential difference across this resistance R, V is equal to current into resistance I into R, I is given as 0.1 into R. So this potential difference across R already we calculated here, that is 1 volt. So from this you will get R is equal to, from this you get R is equal to 10 ohm. Similarly, between R and X together, the total resistance is R plus X, and the current through this circuit is 0.1 ampere. Therefore, potential difference across both resistance together, V is equal to, again current into the total resistance R plus X. We are adding R plus X because both R and X are in series. So this is equal to, I is given as 0.1 into R plus X into R plus X. This is the potential difference across R and X together, R plus X. That already we have calculated here, that is a 2.5 volt. So this is a 2.5 volt. Here already we got R as a 10 ohm. So here R is a 10 ohm. If we substitute R is 10 ohm from here, children, R plus X is equal to, if we take this 0.1 this side, it becomes 25, and here already we got R as a 10. So if you substitute R as a 10, from here you get X is equal to 25 minus this R value 10, so you get 15 ohm. So this is, children. Once again see, children, this is the circuit diagram, and this question is based on potentiometer, and potential gradient is given as a 2.5 volt per meter, and also when you put the plug between A and C, the balancing length is given as 40 centimeters. Therefore, and balancing length means you know that current is through the galvanometer is 0. That means potential difference across this R should be equal to potential difference across this length. So potential difference across resistance R is equal to potential difference across 40 centimeter length of wire. So potential gradient 2.5 volt per meter. So 2.5 volt per meter into balancing length 0.4 meter. So that you are getting 1 volt. And similarly, when B and C are connected, now both these R plus X together come in the circuit. Here also you are getting balancing length. So that means the potential difference across R and X together is equal to potential difference across 100 centimeter length of wire. Therefore, you are getting potential difference across R and X together equal to 2.5 into 1, that is 2.5 volt. And also in this circuit it is given that ammeter reads 0.1 ampere. 0.1 ampere. Therefore, you can calculate what is the potential difference across this resistance R. Potential difference V is equal to IR. I is 0.1. So 0.1 into R. And this resistance, this potential difference already we calculated as 1 volt. So this is equal to 1. From that you are getting R is 10. Similarly, potential difference across R plus X. Again V is equal to IR. So I into R plus X. I is given as a 0.1. So 0.1 into R plus X, that already we have calculated here, that is a 2.5 volt. So equate it to 2.5. From this you are getting R plus X is 25. From there X is 15 volt. Okay, thank you.